Another way to write vectors is by naming its magnitude and the angle that it makes with the positive side of the x-axis. So we're going to see a lot of repetition from our polar coordinate studies. I hope you're able to recognize it. We are going to be dealing most of the time with degrees, so keep that in mind as you are using your calculator. So when we're going to have an angle, we already know how to find the magnitude of that angle, so we've dealt with that. But then think about how we could find the angle. We could do opposite over adjacent because we're going to know A and B. We're going to know the horizontal component and the vertical component. Well, of course, that brings to mind tangent. So we have the tangent of theta is equal to B over A, and then we'll use inverse tangent to find the angle itself. Then other times we're going to want to take something given to us with magnitude and angle and change it into AB form. Well, that A, notice X, remember how that was equal to R times the cosine of theta? That's very, very similar. Our vector serves as the R. The magnitude of that vector serves as the R. And then the B, which is like the Y part, is the magnitude of V times the sine of theta. This link here to a site called GeoGebra, it's really, really handy for visualizing some things, can help us see what we mean by this new way of naming a vector. Its magnitude, if you'll notice, this is a vector that terminates at the point 4, 1. Its magnitude would be square root of 17, or about 4.12. And then its angle from the positive side of the x-axis would be 14 degrees. So that's another way to name the angle for the vector 4, 1. So let's take a look at how we could rename this particular vector in terms of its magnitude and direction by an angle. Well, its terminal point is -3, 2. So I'm going to call this vector V just to have it with a name. The magnitude of vector V is equal to the square root of -3 squared plus 2 squared. So we have the square root of 13 for its magnitude. Now for the angle. The tangent of theta would be equal to B over A. Theta would be the inverse tangent of -2/3. So we go to our calculator, and our calculator gives us -33.7 degrees. All right, so we've got some quadrant considerations here. -33.7 is in quadrant 4. Our angle is here in quadrant 2. So how are we going to get this angle around where it needs to be? Well, that means we need to add 180 degrees to this value. And we get that theta is equal to 146.3 degrees. So vector V, named by magnitude and direction, has a magnitude of square root of 13 and its direction angle would be 146.3 degrees. We can verify that going to the GeoGebra site, and you'll have access to that. You'll be able to use it if you want to. -3, 2, we see square root of 13 as our magnitude and 146.3 as our direction. Okay? Well, sometimes we'll be given the magnitude and the direction in the angle form, and we want to find the answer in component form. Well, to do that, our A is going to be the magnitude times the cosine of 65 degrees. Our B will be the magnitude times the sine of 65 degrees. So for A, we get 845.2, and for B, we get 1812.6. So we could say 845.2, 1812.6, or in terms of I and J, 845.2 vector I plus 1812.6 vector J.